Hey guys, today I'm going to demo a Cwejman VCO-2RM dual oscillator eurorack module. This is a pretty basic Cwejman module. It has two oscillators. Each oscillator has a coarse and a fine tune setting. And each oscillator also has 7 different waveforms that you can set. Anything from a sine wave to various types of triangle and sawtooth waves to a square wave. And you can set different combinations of the waveforms on each oscillator to get some really interesting harmonic sounds. Each oscillator has an input, actually has 3 FM inputs, so 3 frequency modulation inputs, 1, 2, and 3. Currently I have the frequency modulation input 1 on both oscillators connected to the CV outputs from a sequencer. I could hook up an LFO or some other modulation source to FM2 or FM3 if I wanted a little bit more craziness. Each oscillator has 2 outputs. So for example, an oscillator 1 has both a positive and a negative output. Some people wonder, well, what's the purpose behind the negative output? And really the purpose for the negative output is when you put the oscillator into LFO mode. So there's a switch next to each oscillator where you can, and normally when it's up, it's the oscillator using audio frequencies. But if you switch it into the down position, it turns that oscillator into an LFO. So you actually have 2 LFOs in this module. And when you're using the negative output with an LFO, you can reverse essentially, or get the inverse of the signal. So instead of a ramp going up, you could get a ramp going down. And that actually sounds different, especially when you're using an LFO as a modulation source. If you're using the oscillators, if you set them into the square wave, or use actually one of the other waveforms which incorporates part of a square wave, you can also adjust the pulse width on each one of the oscillators. And at the center position, it's about 50%, and I think it goes from about 10% to 90% at the extremes. Of course, you can modulate the pulse width on each oscillator via an input, and there is an attenuator, a level control basically for that pulse width modulation. There's also, I should note, a level control for the frequency modulation as well. So you can attenuate those frequency modulation sources. And the last input is a ring modulation input. So this module, this center input of the module, is a ring modulator output. The normal operation, and if you look at these inputs, you'll see that oscillator 1 and oscillator 2 are both normalized to that ring modulator input, which is kind of handy. Of course, you can override those inputs by plugging something into the X and the Y ring modulator inputs. The other interesting thing I should note, well, 2 interesting things in terms of the normalized connections. If you don't have anything plugged into the FM1 input on the second oscillator, then the first oscillator is actually normalized to that input, that frequency modulation input. So what will happen is that oscillator 2 is going to be frequency modulated by oscillator 1 by default. And then on this, one of the other inputs is the sync input. So you can, at any time you want, you can sync these two oscillators together by using this center switch between the oscillator controls. So you can synchronize the oscillators to one another. You can also externally sync each oscillator individually to an external signal. Now on the second oscillator sync input, if you don't have anything plugged in there, then it'll normalize to using oscillator 1 sync input, which is kind of handy, I guess. So in other words, if you're syncing oscillator 1, then oscillator 2 will automatically be synced to oscillator 1's external input as well. So that's a basic overview of the module. What I will do here is I'll just play some sequences just so you can get a feel for how the different waveforms sound. I will turn off the drum machine that I had earlier just so you can hear the raw oscillator. And I should note that this oscillator signal is going directly to a mixer. It's not going through any sort of filtering whatsoever. So this is pretty much the raw output from the oscillator. And this is a square wave. And I'm kind of changing the pulse width a bit. We'll go to a sawtooth. The oscillator is really musical, has tremendous range, and of course, like any other Cwejman oscillator, it tracks extremely well across the entire keyboard. Some of these waveforms in the middle are kind of interesting because they use different parts of triangle waves and square waves. So you can actually adjust the pulse width and modify the sound of those. Here's our straight sine wave. And of course I can mix any of these waves together. I'll take out the second oscillator just so you can hear one individual oscillator. Let's hear the ring modulator. I'll sync the two together. So as you can see, it's a pretty straightforward module. It's very musical. It is one of these modules that a lot of people say the Cwejman stuff is really precise. I'm not sure I like that term. I like the term predictable. It does exactly what you tell it to do, and you can kind of think of the sounds in your head and what you dial in the module is pretty much exactly what you're going to get out of it. It's a great module, highly recommended. Hope you guys enjoyed the demo. Thanks.